Sean, I would ask you to give a brief introduction to the session, talk about the concept of input-output and algorithms, and then we can have post-presentation.
Yeah, well, I will keep it very brief. I think the only thing I wanted to say was that with respect to this conference, obviously design algorithms are very close to what I do, and the key way that I see much of this conference. But one of the things that may or may not be as obvious to everyone who submitted a paper, I think, and in reading the proceedings, it should be obvious. But one of the unique things that we've done in terms of presenting the papers in this conference is that we have them in two parts. One of the reasons that this conference exists is because those of us who make design algorithms, who spend our time in design, in actually writing code and so on, a lot of the time that doesn't get to see the light of day. That's something that's buried. Eventually the building is built, and that's what gets all the press. But the algorithm itself and the ideas behind it don't always get as much attention as they deserve. So we've explicitly divided papers into two parts. One is the classical sort of academic paper, but the other is a much more explicit representation of what the code, the algorithm, or the data is all about. We've tried to make that more explicit in this conference just so that we can have our conversations more pointed about those aspects of things. So that's, again, what this session is really all about. That's enough for me, I think. I think that should do it. Paul, it's nice to see you.
Nice to see you.
If you're ready to go, please.
All right, thank you. So hi, everyone. Yeah, my name is Paul, and I will present the first paper, which is called Supporting Collaborative Design and Project Management for AEC using Speckle's Interactive Data Flow Diagram. And it's a collaboration between UCL and Grimshaw architects, and also two naval architecture companies. So in terms of content, first I will go through the context, then I will introduce Speckle, which is an open source data platform for AEC. Then I will present the Speckle Viz Interface, which is the core of the paper, its technological framework, visualization features, and interaction features. And then I will go through the two case studies. So one with the naval architecture companies and one with Grimshaw architects. So in terms of context, we all know there is a rising ubiquity of design computation and visual programming amongst architecture practice. And this also leads to more complex and larger scale architectural projects. So therefore, we have seen the emergence of custom technological solutions that enable us to better understand and visualize complex digital workflows, such as the metagraph developed by Woods Bagot in 2017, where they use Flux to track the data exchanges between different software environments, such as Dynamo, Grasshopper, or Revit. Then previously to that, there was also this project, the Morpheus Hotel, designed by Zaha Hadid Architects, and the consulting company Front Inc. developed a very intricate workflow, which is which alternated between different Grasshopper sessions to generate the data and Rhino files to store the data and the metadata. And although there are others, and also although they are very relevant, they are often developed in isolation. And based on this observation, this is why the open source data platform Speckle has been developed. It was actually originally developed by Dimitri Stefanescu during InnoChain in 2015. And this enables us to bring more transparency in the design process. And it enables different trades to seamlessly communicate between different software. And on top of that, the present paper presents the data flow interface, which is called SpeckleViz, which actually maps all these data exchanges. And on top of being just a visualization interface, it actually would allow us to manage all the data in a more efficient way. So as I mentioned, there are two case studies that I will present. L2O and CBS structure, which are two naval architecture and engineering practice. They provided data sets and 3D models for a 35-passenger vessel, and Grimshaw architects who provided data sets for large-scale aviation-related infrastructure projects. I think it was confidential when we wrote the paper, but I will show you renders that are published online. So it's about the Heathrow extension. Just a brief introduction to Speckle. As I mentioned, it's open source, so there are different project contributors who worked in different architecture and practice and software companies. It allows you to connect data between different software, and in terms of the technological stack, you can derive from its REST API, application programming interface, web applications. You can develop new CAD integration from where you can send and receive data. And then you also have an authentication layer, which allows you to log in with your own email and password. Then you also have a web admin interface where you can create streams, create projects, assign tag to streams, and so on. It's a bit like a Google Drive. Regarding the work breakdown structure, so the main space is the project space. Inside you have different streams. And then in these streams, you can have different layers. And in these layers can contain different objects. Now, let's say we have two users, user A that works with Rhine and Grasshopper, and user B that works with Dynamo, the usual suspects. Then user A would create a first stream and give read and write access to user B. User B receives this stream. And then if user B makes more changes, user B will create another stream and give read and write access to user A. So that's really, the workflow is not bidirectional. Like you can't edit a stream that you received. If you want to make changes, you always have to create another stream and send that to the original user. Then in Speckle, you have all the clients. So by clients, I mean all the software integration that keeps track of who send what data from where and to whom. From the Speckle admin interface, it is possible to access the source and receiver clients for each stream. So a map of the project's information flow can be retrieved. And this, we kind of want to finally see the whole project workflow, which is quite a wicked problem, as Sean Hannah mentioned. That would be a sort of like typical workflow where you have different architectural model that fits an architectural BIM model, that fits a structural analysis model, that fits a structural BIM model, and that might again fit back to the original architectural model. So the interface is built within the admin web app of Speckle, and in terms of web frameworks, it used Vue.js, Qt5.js, and D3.js, which allows for interaction and visualization. On the top of the interface, you have all the controls, such as a toolbar, a time range slider, and a tag query selector. And on the bottom, you have the graph canvas itself. In terms of legend, everything in gray stands for old data, and everything more bluish or purple is for the newest data or streams created. And then you have a lot of like emojis or logos where you can see if the data comes from, for example, a Grasshopper definition or a Dynamo definition. You can see if it has been sent or received, and so on. The data flow can be visualized either by software file. So here it's a Grasshopper session with two receivers, the satellite antennas, and one sender, the rockets. And you can also visualize the workflow, same workflow, but by user. So here that's me who worked at UCL. So my initials and the company can be exposed, for example. And here I instantiated 3 senders and 5 receivers. So you can switch between these two workflows. We thought about overlapping them, but it would have been really too hard to understand. It's interactive, so you can zoom, pan the graph a bit like a Grasshopper definition. You can expand and collapse the cluster. Sometimes it also enables you to have more visibility onto the graph. You can always right-click on a stream and view it in the viewer. You can also inspect the data flow per time. So you have a time range slider, and everything outside the time range will be faded out, and everything inside will be highlighted. And then all the streams that are inside are aggregated, and you can see you have a button here where you can click, and all the streams that are contained in this time range can be explored in the viewer. You can also query streams by tag. So normally when you create a stream, you can assign tags, so those are reflected in the graph, and the graph highlights all the streams that are either related here to boundary conditions or structural analysis or whatever you assign. And you can also view the highlighted streams and aggregate them in the viewer app. You can also perform multi-dimensional queries. Also, this is only work in progress, and it's not exposed right now on the interface. So I talked about tags, but you can also filter by when it was created, when it was updated, the tolerance of the documents, the owner, the object number, like everything that Speckle basically keeps tracks of. So that was a brief overview of what the interface can do, but you can check out on the main Speckle website. In the documentation, you should easily find it. And finally, now I move to the case studies. So the first one was to design a vessel between two different small companies. And here I wrote again all the workflow. Basically, I kind of interview them and ask them, okay, so what is the typical workflow in your practice? How can we actually improve it through the graph? And I kind of recreated that diagrammatically first to try to understand, okay, you go from a whole drawing, and then you're gonna add the details, and then this fits to a weight estimation sheet in Excel. So yeah, here is the house design. Here is the data we collected for structural design. The bumper, superstructure, detailing. Here is when all the streams are aggregated. And at the end, yeah, that's there is also a client in Excel for Speckle, so we could also pull all the data. And finally, you actually see all these exchanges onto the graph from design to detailing, basically. But again, that was, I would say that was post-rationalized, because they didn't really use the graph themselves. It's for us who actually went to them and asked them, okay, how can it be improved? So there was no, I would say, critical feedback, which actually will come now with the Grimshaw's case study, which at the time when we collaborated with them, they already extensively used Speckle for the Heathrow project. And so it was a infrastructure urban scale with a team of approximately 40 architects. And to handle the scale of the project, they wanted to have a common data environment, and it was set by the client following information management best practice from the ISO standards. So you can see it was quite a detailed model, and some of it was managed through Speckle. So this is the data flow with different inputs and outputs, different steps in the design process. At the beginning, there were different data points that were fed into Speckle, such as areas, building heights, traffic data, plot boundaries, roads, and so on. Then Speckle was also used to generate the proposed plot boundaries and the allocated program. And then also the streams were used to pass the plot data to master drawings files and a database. And Speckle was also used to send the topological boundaries to Grasshopper for further design development. And also it was interesting because Grimshaw had to follow ISO standard, we also kind of compared the identification of information containers that are set by the standards, and we compare that to what Speckle could provide us in terms of common data environment. So for example, you have different fields. So you have a project. So Speckle has a project called field. So that was possible. Or then you also have an originator. In that case, it wasn't so important because all the data exchange were carried within Grimshaw, not outside. You also have volume system and level location. This could be assigned by just adding some tags to the streams. You had also type as identification fields, role, number, and I would say the most crucial one that we identified was the status of suitability of the data. And those were actually missing in Speckle. I mean, it could be assigned by tags, but I think Grimshaw and I would say other practices would like to see a sort of like specific field for that would say, okay, is this stream work in progress? Is this stream checked? Is this stream valid? Is it obsolete? And so on. So that was a nice feedback we had. So some identification fields were kept undefined for more versatility, and some other were actually missing. Again, the graph functionality was implemented after a few months of Speckle implementation on the project. So Grimshaw didn't really use the graph as a management tool. They kind of deployed it was reflected on the data that they managed through Speckle afterwards. So they sort of like had a look at it, not while they were working on the project. But still, we had nice feedback, some in terms of general user observation. It was quite easy to understand for a design technology aware individual, maybe not for someone who has a more managerial position. So the toggle between the data flow per user and data flow per documents could give interesting insights on the project organization. And the stream filter by tag seemed quite useful and enable an access to further understand the streams, their content and history. In terms of general ergonomics on the interface, although you've seen that we kind of tried to tackle that through the interface with zooming and panning features, it's missed some basic ones such as a zoom extend tool. So navigating the streams wasn't that easy. Sometimes the streams could overlap. So further visualization features could be beneficial, and further analytics could be beneficial as well, such as in how many users, how many active users, empty streams type of data. And also Grimshaw had some main insight is that when they deployed the graph, they realized, okay, actually only one main user is emitting and receiving the majority of the streams. Most of the streams sometimes are sent and received by the same person. And out of the 13 user part of the Speckle project, only 7 are actually contributing to the pool of data exchanged. And some users don't send data to someone else, but just to themselves. And yeah, sometimes it seems also that the streams are sent but never received. So actually the graph highlighted the messiness of the design process. In terms of limitation and opportunities, yeah, I already mentioned that there were poor ergonomics of the graph display, and it is currently quite difficult to get a good overall understanding of the digital workflow through the graph itself. And yeah, also SpeckleViz also reflects some of the Speckle bugs, so that was useful for us to correct some of those. And as a discussion conclusion, yeah, the paper briefly introduced the current challenges in collaborative design workflows within the AC sector, and describe both the open source data Speckle and its related Speckle Viz interface, which aims at representing and managing the activity and social networks operating within the Speckle framework. And yeah, through the two described case studies, the practical implication of the work are that critical issues were identified in terms of process use and functionalities, such as the need for included Speckle in the project BIM guidance, lack of functionalities towards ISO CD compliance, lack of a zoom extend tool, and lack of high-level data analytics, also versioning control system integrated within the graph. But apart from all these challenges, I think yeah, the tag-based query system proved to be very useful, and it encouraged Grimshaw architects to better create their own stream so that they could be more searchable through the interface. And I think in the future there might be some further evolution of this interface that would transform into a more proper management tools, enabling deeper creation, versioning, editing, and deletion of streams and issues management. So yeah, thank you very much for listening, and that's it for me.